Howdy, my name is Malik and I'm a meteorology major at Texas A&M University. This summer, I worked with Dr. Aaron Levine to investigate confident El Nino forecasts made during the Northern Hemisphere spring, where El Nino did not occur the following winter. So what is El Nino? The El Nino Southern Oscillation is a coupled ocean and atmospheric phenomenon that has an irregular 2 to 7 year cycle. The sea surface temperatures along the equatorial Pacific fluctuate from warm and cool periods relative to a 30-year temperature average. The region that is used to determine El Nino conditions is known as the Nino 3.4 region. To classify El Nino events, a 3-month rolling average of sea surface temperature anomalies are applied to the region. If these values are above 0.5 degrees Celsius for at least 5 consecutive months, then El Nino conditions are considered to be in place. During normal conditions, the trade winds along the equatorial Pacific blow from east to west. This causes warm water to be pushed westward and cooler waters to upwell from deeper in the ocean to replace it. However, during an El Nino, these winds weaken, causing the warm water to reach further eastward. Now, what does warm water in the Pacific Ocean have to do with us in the US? During normal conditions, the polar jet extends down into the US in the winter, bringing in Arctic air. However, during El Nino conditions, this jet is pushed northward, trapping in most of the Arctic air in Canada. This leads to the northern portions of the US to experience a warmer than average winter. The warm waters in the Nino 3.4 region also causes the Pacific jet to shift south. Storms that form over these warmer waters then travel along this jet. This leads to a wetter winter across the southern US, specifically in the southeast. This also leads to them experiencing a cooler than average winter. Okay, so for my project, I used 4 specific models that are used for the prediction of El Nino events. I was able to use Python to load the models from the IRI website and combine their hindcasts and forecasts to investigate their outputs from 1991 to 2023. This then allowed me to look at forecasts made during the spring along with actual observations to determine when forecasts were getting things right and getting things completely wrong. So to learn more about the tests I created to help predict when things might go wrong, come check out my poster.